Okay, welcome back. We're talking about Hollywood's depiction of biometrics. They almost always get this wrong. So I'm going to make some movie references because, by the way, you don't have to be a movie fan to do well in this course. It just provides some context. I remember watching some goofy martial arts film. It could have been a Bruce Lee film. I don't really remember. And so he's in some underground, lair, and there's guards everywhere, and he walks up to this door where a guard is, and there's a huge fight, and when he's done, he grabs the hand of one of the guards and holds it up to the little thing, and he goes, and then the door opens. He goes inside. How real is that? I mean, first, there's lots of problems with that. Number one is, why would a guard have access to a secret lab? I mean, he's a guard, for goodness sake. You probably wouldn't give him access. So you would really have to go around the room finding palms that would work. And is there a way for a palm detector to be able to tell if you're conscious or unconscious? Probably not. The other one, Falcon and the Snowman. Okay, again, you don't have to be a movie reference, but the idea was these guys were doing secure communication. He was trying to sell secrets to the Russians, and the thing was, the guard who lets them in the building and walks them up to the door can't see inside the room. Okay. And so they could do anything they want inside that room, to include, take messages and, stuff them in their clothing and stuff and walk on out, because the guards don't have the security clearance to know what's going on inside that room. Okay, good. All right. Now, here's a really cool clip that I really enjoy. So let me just...
This is it.
Is that a retinal scanner?
Let's find out.
Howard Wolowitz, access granted.
No way!
My turn.
Leonard Hofstetter, access granted.
I didn't even have to take my glasses off!
Access denied.
Okay, the point behind all this is that this is funny, and I laughed, but no one uses a single factor, regardless if it's iris, pattern recognition or retinal thing. No one uses a single factor to say what they should have had is a card reader or a password and the biometrics. Okay. All right. By the way, if I had biometrics, I probably would have been doing the exact same thing. I'd be excited. I'd be running around trying to try things. Okay. So on page 302, they talk about, fingerprints and palm geometry, hand geometry, facial recognition, retinal, iris, DNA, that kind of stuff. Now, here's a good question. Let's say I have, identical twins, and they're using Face ID on their phones to lock and unlock. Could that prevent the identical twin, from getting into your phone? Probably not, because facial recognition kind of thing is not perfect. There's an awful lot of possibility of errors. What about fingerprints? Are fingerprints unique in identical twins? No. How about retinal patterns? No. Iris? No. DNA? Well, you could barely tell them apart. I mean, the most basic scan of a DNA would not be able to tell them apart. Okay. So how easy is it to fool like a fingerprint reader? I mean, holding the guard's hand up to the thing and or your finger. In a military grade kind of a system, okay, you could probably check the temperature of something. Like, you can't have a dead man's hand that you're carrying around with you and hold their finger up, that kind of stuff. Okay. Let's talk about retinal scans. So is it really scanning your retina? Not really. It's scanning the blood vessels in your retina. Okay. And if you hold, you're looking at it and it goes, got it. So you would have to have a training session. So this thing on the Big Bang would never work, because they would have had to have gone to one of these machines, had their retinal scanned into the database, and then when they got to the door, it's going to be like, I've seen this before, right? So there's no surprises here. Okay. All right, I'm going to get gross here for just a minute. So just pardon me for getting gross. So some goofy film, what if they pluck somebody's eyeball out? Okay, I know this is gross. Put it in a Ziploc bag, went to the place, pulled the eyeball out, and held it up there. Is that going to work? Well, most retinal scanners, no, because there's no blood forcing through the veins, and therefore all the veins have collapsed, and the retinal scanner is going to say no. Okay, so you can't have a dead man's eyeball. Ugh. Okay, so effectiveness. So there's a little chart here that basically talks about, not everything is perfect. So retinal, and then the iris, fingerprint, palm, facial recognition, voice, and then handwriting kind of thing. That's kind of weird, but okay. So how effective is each one of these things? Well, to tell you the truth, so what I want here is what's called a false rejection rate, or a false acceptance rate. And so what I don't want something that is, false positives can get through, and I don't want something that false negatives are going to drive me nuts. So I want something kind of in between. So this is that the crossover rate, the COR, the crossover rate of the errors. So which one of these is really, really foolproof? I mean, absolutely foolproof. Which one is the best one for not having, a false rejection rate or a false acceptance rate? Fingerprint? Nah. Palm? Nah. Hand geometry? Nah. Facial? Nah. Retinal? Okay, you're getting there. Iris? Maybe. DNA? Oh, DNA would be fantastic, but what? You're going to have a DNA sequencing machine? Again, movie reference. The guy who's trying to get on the spaceship, but he's not perfect. And so every time they walk into the building, they stick your finger on this little thing, and it pricks your finger and produces a drop of blood. And it instantly, like a turnstile, says, "Oh, you're good," and flips over, like within seconds. Is that how DNA testing goes? No, not even close. Okay. But it could be done. Now, is it socially acceptable to give a blood sample to be able to go to work? No. Would people accept staring into a retinal device? Yeah, most likely. But no, they're not going to be consent to give them your DNA. Okay, acceptability, which is what we're talking about. Some are highly reliable, but disliked. Like DNA is unbelievably good, but no one's going to do that. So they talk about ranking the effectiveness. So here is like face. Is it universal? Everyone has a face. Is it unique? Is it permanent? I could get beat up. I could have a car accident. My face geometry could be swollen temporarily, right? How easy to collect? Easy. I just, get a picture taken, so to speak. Face thermogram, fingerprint, hand geometry, hand veins, iris. Ooh, boy. Now retina. Ooh, boy, you're getting there now. Odor and scent, I've never heard of that. Voice, that's how they always do it on Star Trek. Signature, no. Keystroke, no. Walking gait, no. But you really want a lot of these things in the red here, where you have, everyone has an eye, and it's unique, and it's relatively permanent. I mean, I will tell you, if you go scuba diving, you could bust a couple blood vessels in your eye. Yeah, that could happen. How difficult is it to collect? Et cetera, et cetera, et cetera. And is there any way you can circumvent it? Not really. Okay. So one more time. Just to make the point clear, no one uses a single one of these as their only means of doing authentication. Even the good ones, like iris, okay? Or retina, rather. Everyone uses multiple factors, right? I give them my name and password and this, or that will be, two-factor. Okay, so let's talk about the access control architecture models, page 304. And so these are models. They're not like directly implementation kind of a thing. They're used to lend credibility to like hardware and software stuff, right? All right, so the one called Trusted Computer System Evaluation Criteria, the TCSEC. This is a so-called orange book. It got replaced by the thing called the Common Criteria, which is now considered, like the rainbow standards. There's a whole bunch of different colors. It was just the orange book, but now there's all different ones. And it covers what's called covert channels, like someone's listening in on a conversation. So storage, to include things like steganography. I'm hiding text inside a graphic file. Timing, to include, I can almost tell what the message is by the how fast the packets are coming in or how they're separated, those kinds of things. And then the information technology system evaluation criteria, that's kind of an international version of the DoD one. And then the so-called common criteria. This has been adopted as an ISO standard, and this is, evaluation assurances. You get a rating between 1 and 7 on how well your computers are set up and, how your communication system is all set up. And there's a bunch of these things. I'm just going to go through them rather quickly because individually they're not that important because these are just models. You pick one to go with. So a Bell Laputa has a state machine. Basically, it's about, like a read-write model if you've done modeling before. Who has permission to do this and what this happening means, all that stuff. The BIBA integrity, higher levels are more trustworthy. That's their thinking. Clark Wilson, like it's all about change control and internal consistency. Graham Denning, you have objects, subjects, and rights. And then there's a bunch of other. Brewer Nash, and then Zero Trust, page 308. Now, you've probably heard of Zero Trust, and it's almost always used in context of cloud computing. And the idea is, I'm very good inside my envelope. Everything inside my building, I got that down. I mean, you have to have, this, and you have to have this, and you're using retinal scans, and, you have locked doors, and it's all perfect. But when I'm going to a cloud provider, I don't have that capability, right? I have to say, well, okay, if the person says who they are and I can verify it at my end, then the other guy is just going to have to accept that that's okay. Now, does that make you squirm just a tiny bit? Yeah. So Zero Trust was basically saying, no. Every time you go to a cloud provider, you're going to have to provide me something, okay? And hopefully more than just one factor. Hopefully it's not just a name and password that you can save in your browser. So whenever you hit something, it automatically authenticates you and go. I mean, if this is important stuff to you, you're probably going to have like a security token or something else. A retinal scanner remote probably doesn't make sense. But you could have, call you on your phone and, put a text message or something that says, when I go to my bank, I give them my name and my password and they immediately hit me up with a text message. I have to type in the numbers, right? Okay, that's what we're talking about. And so, do you understand why? I can have everything great inside my building, but when I leave my building and go to someplace else, I can't bring that trust with me. So I have to have zero trust model, which basically means there's no transitive trust. If I trust Bob and Bob trusts you, well, too bad. I don't trust you at all, okay? There's no transitive trust. I don't trust anyone in between, okay? All right, does that sound like a good test question to you guys? Just check. Okay, Firewall Technologies. We're getting ready to leap into some technical stuff here on page 308. So it's designed to prevent information from moving between two different levels of network. Mostly we're talking about the clean network inside your building and the dirty network on the outside. You're trying to prevent things from the outside going in and to some extent from the inside going out. Anyway, they're called zones. And so the trusted zone, the clean zone, that's the LAN inside your building, okay? The untrusted is the dirty, and most likely we're talking about the internet. And sometimes there's one called a demilitarized zone, a DMZ, which is sandwiched in between. It's sort of like semi-trusted. So you have trusted, untrusted, and semi-trusted in the middle. And you have to define the zones, and you have to decide this server goes into this zone, okay? That's how that works. It could be hardware or software based. Hey, we're coming up on the 15-minute mark.